protein is critical for its function. If we destroy the structure of a protein, we destroy its function. Period. Okay? Forces to stabilize structures of proteins are therefore very important to understand. We destabilize the structure of a protein through a variety of ways. Detergent will do it. One of the ways we kill bacteria in our hands, we wash our hands. Detergent, soap does that. The reason we cook our food, denaturing proteins in the bacteria and so forth in the food allow us to not be destroyed by the bacteria that's in there. And the reason that cooking and washing our hands and so forth works because we are destroying the structure of proteins that are part of the bacteria that are there. Okay. Another consideration we'll have are van der Waals forces. And van der Waals forces are a little hard to understand. There's only one thing you take out of what I'm going to say about van der Waals forces here is this. And that is that van der Waals forces define for us an ideal distance of interaction. An ideal distance of interaction. If we look at trying to put two nuclei together, what we discover is that from a certain distance apart, there actually is an attraction. Okay? An attraction. The further down we are here, the more attractive, the stronger the attraction. So we start putting these nuclei together, we decide to get closer and closer and closer, and we discover, wow, they're getting more and more attracted to each other. It's kind of like singles dating or something, right? That you're on the computer and here you're getting closer and closer to this person that you've been communicating with on the computer, and the attraction is getting stronger until you actually meet them. Okay? And then when you actually meet them, you get this sort of revulsion, thinking, oh my God, what have I got myself into? How in the world did I ever think this? Get me out of here, please. And the repulsive forces take over at that point. Okay? Now, repulsive forces, what this means is that you try to put two things together that don't want to go together, not unlike online dating, okay? You try to put two things together that don't want to go together. The repulsion, after a certain point, goes up to the power of 12 as the distance decreases. This repulsive force is enormous. That's why we can't put atoms too close to each other. And that's going to be a very important consideration for us when we look at the structure of proteins. Van der Waals interactions tell us that we can't put two nuclei too close together, because if we try to put them too close together, they're going to fight with all their might, and I'm not going to be able to overcome that repulsive force. That repulsive force dictates how close together we can put atoms. And we start folding proteins, and we start putting atoms in close proximity that weren't in close proximity. We've got to limit how closely we can put them together. And that will determine things about how a protein folds. Okay, ice. There's ice. Memorize that structure for the exam. Okay. Hydrophobic effect. Okay. Now, I'm talking about some very general things here, and I will be honest with you, the first lecture is kind of chaotic because it's very much of an introduction. But I'm going to be talking about all of these things in some more detail as we go on. I'm just kind of scratching the surface here. I guess what I'm trying to say up front is I'm not totally as disjointed as I am the first exam on the first lecture. I can be pretty disjointed, but I'm not as disjointed as I used to be in the first lecture. Hydrophobic forces. Hydrophobic forces are also important forces that are involved in determining protein structure. Hydrophobic forces. Hydrophobic forces, you already know about a little bit. And what you know about hydrophobic forces are the fact that oil doesn't mix with water. Oil being hydrophobic tends to associate with itself. Water being hydrophilic, being more polar, tends to associate with itself and have this point shall meet. If you take a bottle of oil and vinegar, oil on the top, vinegar on the bottom, vinegar being an aqueous solution, and you shake it up, what happens? What do you see? You see droplets. It sort of mixes. It doesn't really mix, but you see little droplets. What did you just do? You applied energy, shaking, shaking, shaking. You're forcing something apart that doesn't want to come apart. And so they sort of mix. But what happens when you set that bottle down? It separates, right? Why does it separate? It separates because of hydrophobic interactions. Look at this up here. When I have those little droplets that I shook and shook and shook, what I did was I gave those little droplets of oil, in this case, immersed in water, let's say, or vice versa, this going down. When I do that, if this is oil, and these are water molecules that are run around here, these guys end up being extraordinarily organized. Nobody wants to go over next to this guy, but this thing's immersed in the middle of it. Okay? It's kind of like being, I guess, at a party, you've got one smelly person. Okay? And nobody wants to be around it, so everybody tries to get an equal distance away from this so that you don't want to be around that smelly person, right? Okay? You help with your hair. You organize yourself sort of as far away as you can get, and that's what these water droplets are doing. It becomes very organized. The second law of thermodynamics tells us that disorder is a force in the universe. Disorder is a force in the universe. It's a driving force if nothing else is there. There's no heat involved here. What brings these water droplets together is the fact that when we start putting water droplets together, we have less surface area per total amount of material. Therefore, we have less order. Disorder is driving this to the right because there's less order around. If we add all the ones here that are ordered and all the ones here, and we compare them over here, we'll see that we have more in this case than we have in this case. So by coming together, we're favoring disorder. We're favoring entropy. We're favoring the second law of thermodynamics. That's pretty cool. Okay. So hydrophobic forces are important forces for us to understand. Questions on them? Yes. Water is a polar molecule. Okay. Well, let's turn our attention then to thinking about not thermodynamics. And by the way, we do touch on thermodynamics, this term that will happen later in the term. We're not going to focus on thermodynamics now, but we'll see later why that's important, because thermodynamics allows us to predict directions of reactions. We're going to see how important that is later. But instead, I want to actually dive into some material that you probably think you know, and you really don't. And that's because your freshman chemistry class really didn't teach you crap about chemistry. Okay? didn't teach you crap about chemistry. And that's not your fault. I think in some cases it's your fault, but it's perhaps more a fault of the fact that we haven't really figured out practical ways to teach chemistry and mathematics. I'm a practical person in terms of chemistry and mathematical knowledge. I want things to have real meaning for you and not abstract meaning for you. That's not always possible to do, but I think it's important to figure out. Let's start with definitions. You learned in freshman chemistry, if you didn't, you will now. pH is equal to the negative log of the hydrogen ion concentration. Log being a logarithm being something that anyone who's taking a senior class in science should know. Okay? That's what you should know. That's essential for you to know. On a chance, I will not require you to memorize equations. I will give you every equation you need to know. There will not be one equation you need to memorize. You will need to manipulate that equation or those equations to show me your knowledge. You will not be able to use a calculator. Why? Because calculators allow you to manipulate equations. And you're the ones to manipulate the equation. Okay? Now, I'm not going to ask you what the logarithm of 4. You have to figure it out. That wouldn't be fair. But you will have to understand what logarithms have to do with this equation. Okay? Now, pH is negative log of hydrogen ion concentration. The pH decreases. Hydrogen ions are a measure of what's responsible for an acid. The more hydrogen ions we have present in a solution, the stronger the acid. Notice that it's the concentration of hydrogen ions. Concentration measured as moles per liter, which is the same as molar, which is a capital M, which is not the same as moles, which is what I find half the people in this class don't know. Freshman chemistry fails you. You didn't fail freshman chemistry. Freshman chemistry fails you. How do you like that for right? Hopefully biochemistry won't fail you either, but if that happens, you can blame me. Okay. Now, conversely, the PLH. We don't hear much about the PLH, but the PLH, by the same definition, is just a negative log of the OH minus concentration. As the hydroxide ion concentration goes down, it goes up, the PLH goes down. Okay. I can talk about the T7 ahern, and if I talk about the T7 ahern, I would hope that you would say, well, by logical extension, that would be the negative log of 7 ahern. And as the 7 ahern concentration goes up, the T7 ahern goes down. Right? Okay, and so you start to see a pattern. We can therefore talk about pKa. pKa is known as the acid dissociation constant. And I always slur that when I try to say this fast. The acid dissociation constant, okay, which is a measure of the strength of an acid. The pKa, which is the Ka of the acid dissociation constant. The pKa is the negative log of the Ka. Well, what is the Ka? The Ka is shown right here. Okay, you look at acetic acid, for example. Acetic acid, which I abbreviate as HAC. When we put it into water, it dissociates into protons as an H plus and AC minus. The Ka then is the concentration of protons times the concentration of AC minus divided by the concentration of HAC. What does that tell us? It tells us, first of all, let me ask you guys, what does that tell us? What does that tell us about this acid when I put that up here on the board? Anybody, what does that tell us? What does the fact that I have this equation here tell me about what's happening in this reaction? I bet nobody can tell me. It tells me what? And what does that mean? Oh, okay, very good. Where are you? Good. Okay, it tells you how strong the acid is. We talked about this class about strong acids and weak acids. Okay? For the most part, we're going to be talking about weak acids in the class. Strong acids aren't applicable to this equation. Do you know why? They completely ionize. Okay, so if I have HCl, when I put it in water, everything goes to H, and everything goes to Cl minus. When I have acetic acid and I put it in water, that's not what happens. So you get an idea. If I take 10,000 molecules of HAC, that's my study material here, 10,000 molecules of HAC, and I put those 10,000 molecules of HAC into water, we'll start with HCl. Those 10,000 molecules of HCl in water, I get 10,000 protons and 10,000 chloride ions, completely dissociated. If I put 10,000 molecules of HAC into water, one of those will lose a proton, making one proton, one AC minus, and 9,999 HACs waiting there to do something else. That's a weak acid. And as weak acids go, HAC is fairly strong. Okay? How do I measure the strength of a weak acid? I said it was fairly strong. How do you suppose I would measure the strength of a weak acid based on the things that I've already talked about? Nobody? No? Well, how much would associate based on what I talked about? How would you measure that? pKa. Okay. The lower the pKa, the higher the Ka. The higher the Ka, the stronger the acid. So the lower the pKa, the stronger a weak acid will be. If I look at the pKa for acetic acid, it's 4.76. Okay? If I look at the pKa for various groups of amino acids, I will see that they may be anywhere from 6 or 7 or 9 or 12. In some cases, I have a pKa of 2 or 4. I would certainly hope that if I asked you to give you two acids and I said one acid has a pKa of 2 and one acid has a pKa of 4, you could tell me which one was the stronger of the two acids. One of the problems that I give you, it has exactly that sort of phenomenon there. Tell me why, based on these pKa's, that this is true. You'll see that in the problem sense. Now, you'll notice I haven't said a word about bases, I haven't said a word about conjugate acids, conjugate bases, or anything, and that's because I like keeping it simple. We're not going to talk about bases in this class. For one time, we're going to use the word base. Because we use the strong base. Sodium hydroxide is a strong base. Based on what I said about strong acids, what would your definition, what happens to sodium hydroxide in water? It completely dissociates. We will not use the term base for something that accepts the proton. We will use the term salt. People really want to get this class. See, come here. Okay. We will use the term salt. Right? And the reason for that is when you start using the term base, you will get confused based on what your notion of what a base is. Okay? Now, I see that the old clock on the wall is saying it's time to cut short. Let us cut short, and I will see you guys on Wednesday. So I'm going to take you through it step by step. This first lesson, we're going to make a light blink, and then we're going to go all the way to showing you how to build an instrument package based on the Arduino for supersonic into space. This is a picture that was taken by an Arduino-based system that we developed and sent to 120,000 feet. So we're going to start by blinking an LED, and we're going to go all the way to being able to build a space probe. Not all in lesson one. Lesson one will be blinking the LED. But what I'm going to do is I want you to know if I'm going to harder than, installing a printer or something like that. So first of all, we need a microcontroller. The microcontroller we're going to be working with is the Arduino. The reason I chose the Arduino is there is such an incredible amount of infrastructure out there. Almost anything that you want to do with the Arduino, someone else has already done. There's incredible resources, incredible infrastructure, and you can get the Arduino for about $20. And so it's a very affordable platform to work on. I've got some resources listed on my website, toptechboard.com. If you visit there, I can probably get you hooked up with one, or you can find one in any number of different places. The thing about this is, if you can get the bare Arduino for about $25, I'll show you down here one that's set up and ready to go. And what I'm going to suggest is, if you're going to go through this, I would suggest that you go ahead and buy the SparkFun Inventor Kit. The thing about the SparkFun Inventor Kit, it has all the wires and connectors. It has all types of components to take you through about 10 or 15 different projects. The SparkFun Inventor Kit comes with a number of different sensors, a number of different actuators, and a lot of these subsequent lessons are going to be based on components in the SparkFun Inventor Kit. The SparkFun Inventor Kit is about $100. To me, it represents a really great value. You could probably go out and try to buy all the different parts yourself, just starting with the bare Arduino, but I think in the end, you're probably going to be better off to go ahead and get the SparkFun Inventor Kit. SparkFun is a great company, had great luck with them, and highly recommend their products. Okay? But today we're just starting with the bare Arduino, and we're going to see how you would go about working with it. First thing is, you're going to just take a couple of minutes to install some software. Really, this is no harder than if you did something like install a printer. The best place to go to do this is you can go to this website, which is called the Arduino website, and it is at arduino.cc/en/guide/windows. Okay, if you go there, it has a quick overview of how to download the software. The first thing you do is you download the Arduino environment. That is your integrated development environment. That's the palette on which you will create your platforms. Just click on the download page. I'm on Windows. I downloaded the Windows software. You click on it, and it installs it. Very, very simple. And then basically what you got to do is plug the board in. There's a USB cable over here. You just plug it in with a standard USB cable. Nothing difficult there. And the final thing is you have to show the Arduino where the drivers are. You can go through this, but it's basically very simple. You go to the device manager, you right mouse click on that serial port, and then you point to where the software is for the drivers. This takes you through it in a little bit more detail. I think you should probably do this in about 5 or 10 minutes, so I'm not going to bore you by taking you through step by step with that. But once that is installed, then what you do is you launch your Arduino environment, and it comes up looking like this. So the first thing that you're going to see is every Arduino program has two parts. It has a void setup, where you set the Arduino up, and then it has a void loop. The things that you want to do one time, by setting up your pins, you will do in your void setup. And the things that you want to do over and over and over, you do in your void loop. And so basically two parts of the program, the void setup and the void loop. But before you actually get going, there's two things that you need to set in your environment. The first thing is you have to tell your integrated development environment which Arduino board that you have. Chances are you have the Arduino Uno. Okay, I have the Uno Rev 3. Almost all Arduinos out there are the Arduino Uno. And so that's what you have by going to Tools and Board, and you can see here that mine is already set on Arduino Uno. But you want to go ahead and do that. Do that, because if for some reason that is not set right, you will have problems.
The second thing you have to do is you have to tell the environment for support, for serial port, your board is connected system. And to do that, you come down to tools, port, and you see that mine's on COM11. You want to go ahead and check though, because sometimes you have more than one option here, and you've got to tell it which one it's on. And if you see like it pop up COM4 and COM7, how do you know whether your board is on COM4 or COM7? And I'll show you. You come over here, and you get the Arduino, okay? You see mine's already on the serial port, and you unplug it. When you unplug it, you hear that all of a sudden the USB is not happy because you heard that ding-dong because you've unplugged something from the USB that it doesn't like. I come back, now you see that COM11, that port 11 is no longer there. It has disappeared. Because COM11 disappeared, that tells me that in fact my Arduino was on COM11. So let's come back, put this back, and now we're going to be pretty sure, get that nice peak there, we're going to be pretty sure when we come back to port COM11 is back. So that tells us, yes, in fact, our Arduino is on COM port 11. Now the reason I go through all that is a lot of times when you plug it in, there's more than one choice, and that's why you can absolutely positively make sure that you've got it set on the right choice. Okay, now let's see if we can make this do something. And so basically, if we look down here at the Arduino, we can see that there's all types of different pins. On this side, there are basically 13 different pins, starting at pin 0 all the way up to pin 13. After pin 13 is a ground, so if you want to use an external circuit, if you want to do something, you can connect to the Arduino ground through that one. But right now, we're going to be talking about pin 0 through 13. If you have an external breadboard, which we'll talk about in the next Arduino tutorial, you can bring those pins out and you can start turning LEDs on and off. But today, we want to make it where you write your first program, and we want it to be as simple as possible. And so to make it as simple as possible, there's a little thing here, and that is, let me see if I can focus this a little better. There's a little thing here, and that is that on pin 13, there is an LED on the board already hooked up. This little LED is hooked up to pin 13. And so if we do something to pin 13, that connects to that LED. And so let's see if we can turn that LED on as our first program. Okay, our very first program. Well, if you're going to talk to pin 13, you have to tell the Arduino what pin 13 is, and you do that as a pin mode. You set your pin modes. Of all pins you're going to use, you have to set your pin modes. You set them one time, so you do it inside the board setup. One of the things about this programming language is that the clauses begin with an open curly bracket and they end with a closed curly bracket. So we say void setup, okay? That's going to be kind of like my clause, that's going to be kind of like my paragraph. It begins with the open curly bracket and it ends with a closed curly bracket. Everything you do in Arduino, anytime you have any type of clause, it will begin with the open curly bracket and it will end with the closed curly bracket. Everything that you do between those two curly brackets will be that clause, the setup. But what do we want to do? We want to do our pin modes. How many pins are we working with? This time only one. We're only working with one because we're only working with pin 13. So we have to set our pin mode. So we have to go pin mode. You have to do it exactly like I'm showing you here. Notice that it's PIM and then capital MODE. That's also called funky text. It's used a lot in programming. And that is you don't want to put spaces between words, but the way you sort of show one word from another is you make capital the first letter of the next word. So you can see this is the word pin mode, and it has to be capitalized like that. That is space sensitive. Now you open up your parentheses and you put your arguments inside of these parentheses. And the arguments that you want is you're going to set up pin modes. You have to tell it which pin are you setting up. I'm setting up 13, and it can be either an input or an output. If you're going to be reading from pin 13, it's an input. If you're going to be writing to pin 13, sending an output to it, it's an output. We're writing to it, so we're going to say that it's an output. Also notice that output is case sensitive. It is all in capital. Notice to pay attention to the colors. That because pin mode turned orange because the Arduino recognized that was a command. Hey, I recognize pin mode. I know what you're talking about. So when I see this pin mode turn orange, it kind of gives me a warm, fuzzy feeling that the Arduino environment recognizes what I just said. Also, when I type in output, it kind of turned blue. That's telling you that Arduino recognized that word. And so what we have here is we have now told the Arduino that pin number 13 is going to be an output. We're going to be sending information to it. So now that we've done that, we can come down here in our void loop and we can do our first command. And what we are going to do is we are going to do a digital write. And so what we're going to do is we're going to turn pin 13 on. We're sending pin 13 high. But basically what you're doing is you're sending a 7-volt signal to pin 13. When I send I'm sending a 5-volt signal to pin 13. When I send a 5-volt signal to pin 13, and that should turn this little LED on. So what we're going to do is we're going to do a digital. We're writing to pin 13, and what are we doing? Are we sending it high or are we sending it low? We are sending it high. Okay? So then all lines just about in the Arduino end with a semicolon. So when I did my pin mode, I ended with a semicolon. When I did my digital write, pin 13 high, that went into the semicolon. Now, just because I write it on this screen does not mean that it automatically goes down into the Arduino. To put it into the Arduino, it's got to be compiled, and then the code has to be downloaded. And we can do that with the click of one button. This is this button. What this button does is it compiles the code, and it sends it on down to the Arduino. So if I click this and I've done everything right, I usually hold my breath because I may cause a mistake. You see that it's compiling, everything's green, that means it's happy, and if it's gone down in there, and look what happened. We sent that 1013 high, and that turned that LED on. If we brought a wire off of this 1013 and externally hooked it to an LED, that would turn the LED on. Well, that's kind of exciting. If I can turn this LED on that's on board, I could bring a wire out, and I could jump it over to something else, and I could turn an external LED on. And the cool thing is that if I can turn an LED on, I can turn a motor on it. If I can turn a motor on, I can open the door, open the window. And so even though this is a very, very simple command, it's very, very powerful because now programmatically, I just send a voltage to a pin. So if I turn an LED on, it could be a motor, or it could be a servo, or it could be any number of different things. But we put in our first program and we downloaded it. So I hope you followed along with me, and I hope that you've been able to write your first program. Now, I'm going to do one more thing in this video because I think that we've made some good progress, and I just want to show you one more little thing, and that is that one is a good programming practice. Once you come down to the program, say 13 and then write 13. Let's stay around with two more requirements if we're provided to use that. Let me just go ahead and say, what if you think we could turn that LED off? What if I would want to set this to if I wanted to turn the LED off? I turned it to high and went on. What would you do if you wanted to turn it off? Well, how about we make it low? That's probably what you would have guessed. So wait a minute. The LED didn't go off. Why did the LED not go off? Because I had not sent this code down into the Arduino yet. Remember, we got to compile it and send it down there. So I put this, it's compiling, so it's sending it down, and it turned that off. And it turned it off. Let's see if we can turn it back on. We're going to go high. Is it high? You have this go right. Okay, and watch this over here, if we're watching. Okay, the LED comes back on. So you can turn it on, we can turn it off from our program. Now, one of the things I wanted to consider in this first lesson is it's really very cool programming practice to come in and say, turn 10, make 10 to 10 mode of 13 and output it into select 13. So as you program this more and more and more complicated, get more and more stuff, but it's harder to keep track of. So what you want to do is you want to set very